Suppose we had some water in a drainage pipe like this, and somebody wanted to measure from up above. They wanted to measure how much water was in here without getting in it like this guy is right now. How do we figure that out? How do we figure out how much water there is? Well, interesting enough, we can use a formula that is actually used for an arched window. All right, so here we have a picture of what the water looks like as it flows through one of these big pipes, like under a city. And we want to figure out the width of it. Now, if we reach down from up above, we can see the height of it. Okay, and we want to figure out this width maybe to know how much water is actually flowing through the pipe. Well, we can use this formula here. Okay, so R is the radius of the pipe, which we can know. And we've got the width of the water, which we're going to actually want to find out. And we know the height by putting a stick down in the water to figure out how deep the water is. Okay, it gives us this part of a circle. So let's see if what we can figure out. So suppose we've got a situation where we have a 12-inch pipe. We've got 8 inches deep, so that will be our H. H is 8. And we want to know we got a radius of 12. All right. And we want to know what that width is. Okay, well, let's use this equation. R equals W squared plus 4H squared all over 8H. Okay, and then first step, we're going to plug in what we know. So we know the radius is 12. We know we actually don't know the width. That's what we're trying to solve for, W. And we've got a height of 8. 4 times 8. I want to put that in parentheses so it doesn't look like 48 squared all over 8 times 8. Okay. First thing we want to do here, we want to solve for W. So we probably want to clean this up so we can do this little 8 times 8. Let's work this out here. Okay, and then we'll need to get rid of these numbers over here so we can get W all by itself. All right, so let's go ahead and do a little arithmetic here. 8 times 8, well, that's 64. Here we got 8 times 8 times 4. All right. So square first. Order of operations says we square first. Got to make sure you do that. Don't do 4 times 8 first. Okay. So 8 times 8 is 64 times 4. We can get a little help from our calculator there. So your scientific calculator, if you type that in there carefully, will actually be able to work it out for you. 4 times 8 squared. 4 times 64 is 256. Okay. So we get 256 for 4 times 8 squared. Okay. So 256 and W squared. All right. Now, going to solve this equation, so let's remember some algebra. Okay. We can't divide these here because when there's two things being added, you would have to divide them both. But we want to get rid of the 64 first. We're going to get rid of that. Now this fraction means divide. So when we have a fraction, fraction is divide, and the opposite of divide is multiply. So we're going to multiply both sides by 64. We've seen, like, remember when we were talking about our units and canceling the units, the opposite, when units are on the bottom, we wanted to multiply them. That will cancel. You don't need to distribute out to 64 or anything. Just cancel it out. And so we have W squared plus 256 equals whatever 64 times 12 is. We'll let our calculator do that. 64 times 12. All right, we got 64 times 12 is 768. So 768 there. And we're almost there. So the opposite of adding is subtracting. So let's go ahead and subtract 256. And let's see. 756 minus 256. Well, we don't need a calculator for that. Just subtract. 8 minus 6 is 2. 6 minus 5 is 1. 7 minus 2 is 512. Okay, now we're almost there. Remember, we're always copying our steps down. Work down the page. Okay, do a step, copy what's left. Do a step, copy what's left. Okay, and so then we got to ask ourselves, what's the opposite of squaring? W squared. Double squaring means multiply by itself. So the opposite of squaring is square root. Okay. So we want to get rid of that squared because we're trying to solve for W. So the opposite of squaring is the square root. Okay, so square root and squaring are opposites. They undo each other. And so that leaves us with W. And whatever the square root of 512 is, let's go ahead and figure that out. So the square root of 512, that's this key right here. That's the square root key. Every scientific calculator will have something like that. All right, and it's a decimal number. We got 22.627. All right, 22.627. And that would be inches. Okay, now, well, we asked to round it too. We didn't tell us specifically. Okay. So we can always leave extra because you can always round it more. Probably 22.6 would be plenty fine, but let's leave it like that for now. So that's the idea, okay? So we substitute, and then we solve. We got to make sure that we multiply to get that denominator out of there, and then we got to subtract to get that leftover, the opposite of adding. All right, let's look at another one. All right, let's check out another equation with an engine displacement. We've seen this formula before. All right, we've got the displacement of an engine, which means the amount of volume inside this cylinder, is given by this formula. Okay, and we've solved this before until we figured out what the displacement is. If we know all these things, if we know the bore, the stroke, and the number of cylinders, that'll tell us how much volume is in there. More volume means more power. Ooh. But we got a different situation here. Now we want to find the bore. We don't know the bore for a 6-cylinder. So 6 cylinders, that's the number of cylinders here. And a 6-inch stroke, all right? So that's going to be S with a 278 cubic inches of displacement. So that's going to be D. Let's plug that in and see what we got. We've got 278 goes in for D. We're using this formula here now. 278 equals pi times the bore, which we don't know, B squared, times S, which is 6, times C, which is 6 all over 4. All right, so we can do this a couple ways. We could get this 4 out of here, or we could kind of simplify this 6 times 6 over 4, because there's no plus up here. Probably the safest way would be to go ahead and let's get rid of that 4 like we did before. It's divided by 4. Let's multiply by that denominator. Okay, multiply both sides by that denominator. You can use your calculator, that's fine. 278. That gives us 1,112. All right, so 1,112 equals, and we're left with pi. Now I'm going to rearrange these numbers up top. 6 times 6 times b squared. It's all multiplied, so it doesn't matter what order. Okay. And in fact, I'm going to rearrange these. Let's do this. Let's multiply the numbers that are not pi. Okay, now pi is a number that you probably have some experience with. It's about 3.14159. All right, so it never ends and never repeats. Well, let's leave it alone for now. This is 6 times 6. That's 36. We can do that. Pi b squared. Now, it's best to kind of leave that pi alone for now. And what we're going to do is we want to get rid of that. We have 36 pi, which is a number. You can go to your calculator and get that decimal. Times b squared. Let's divide. What do we want to divide off? We want to divide the 36 and the pi. 36 pi. What you do to one side, you got to do to the other. Okay? And so this will cancel out that whole 36 pi. And we'll just type this into our calculator here. Okay? So I have 1,112 divided by 36 pi. Okay? Now with Desmos Scientific, it works real nice because it gives us that division. It's going to look exactly like that. We have 1,112 divided by 36 pi. Now, if you have a one-line calculator that doesn't type this and show you this fraction here, like if you even just a basic calculator on your phone or something like that, you need to make sure you put that in parentheses. Okay, so we get 9.832. Let's cut it off there for now. 9.832. That would be b squared. Okay, so again, notice that cancels, and so we're left with 9.832 equals b squared. We're not done yet. Don't forget to copy the squared down. What's the opposite of squaring? Well, the opposite of squaring is the square root. So we're going to square root that number. Now, I have written we're going to square root 9.832, but I'm going to leave this in my calculator and square root that whole number. So if we square root, use our square root button here, and instead of typing 9.832, I'm going to use the answer key to bring that down here. And we get 3.1356, and I don't know what we want to round to. 1 decimal place it says. So 3.1. So B is approximately 3.1. So that's the idea. So remember, the opposite of squaring is square rooting. So we want to get rid of that denominator is what we did. We did a little cleanup with the numbers that were not variables. Remember, pi is not a variable. If you want to multiply this out and get a decimal and then divide by the decimal, that works fine also. Just make sure that you don't round the decimal off until the end. Don't round it off too much. Okay, one more, and then we'll wrap this up. Here's another formula we've seen before. This moment of inertia, which tells us how stiff a beam is. It's a measurement of will a beam bend or not. All right, so we've got these beams that hold up a floor. Want to know if they'll bend, all right? So here's a situation. We got the formula. We know where this is. I is the moment of inertia. B is the width of a beam. D is the height. All right. And let's plug in some things we know. All right. So we've got the height of the beam around it. We want to find the height. All right. So we want to find the height. We want to find D. D is the height. To the nearest eighth of an inch. All right. And B is 5 1/4, and I is 3,250. So they tell us what that is. So 3,250 is I. We're going to use our formula up here. All right. So plug it in. 3,250 for I. We know what B is there, all right? And so we got 5 1/4. Now we want to change that quarter into a decimal. So we know, a quarter is 0.25, so 5.25. Now, if it's not a decimal, remember you can divide it. Hopefully you don't have to for 1/4. We know quarter is 0.25. Just think money. Okay, but 5.25, that goes in for B, and then we're trying to solve for D. This is D to the 3rd power now, all over 12. All right, well, we'll deal with that 3rd power in a second, but we see kind of the same kind of form here. We got this 12 on the bottom. Okay, so this is all divided by 12. So let's get rid of that 12. Multiply both sides by 12. Okay, so by the way, let me back up for a second. Why would we want this? Well, here we're saying we need this stiffness of the beam, all right? So the contractor might say you got to have a beam with this moment of inertia. Okay, and we know the width here. Okay, then maybe that's the width of the beam that fits into a certain slot. Okay, and then we want to figure out, well, how tall would that beam have to be? That's what we're going for here. Okay, so 12 times 3,250. All right, 12 times 3,250. Looks like that is 39,000. 12 times 3,250. 39,000. Okay. 39,000. And multiplying is the opposite of dividing. That's gone. So 5.25 times d cubed. Copy it all down. Okay. Now we've got to divide by this because this is being multiplied. So let's get rid of that 5.25. The opposite of multiplying is dividing. We always do the opposite. Makes sense? We divide there, and that's going to leave us with d cubed. Let's go see what that is. 39,000 divided by 5.25. So we got 7,428.57. All right, 7,428.57. All right. Now I'm going to write down 7,528.57. I'm going to leave that in my calculator because we're not done yet. We need to get rid of this 3rd power. Well, we know this. Okay, let's back up. Okay, so we know 5 squared means 25. The opposite of squaring is the square root. So the square root of 25 is 5. Okay, squaring means multiply by itself. 5 times 5 is 25. If we have 5 to the 3rd power, that's 5 times 5 times 5. 5 times 5 times 5 is 125. Now, if I want to undo the 3rd power, or what we call cubing, we can do the cube root. This means what number cubed is 125? And if we think about it, what number cubed is 125 is 5. So the opposite of squaring is the square root. The opposite of cubing is a cube root, okay, or a 3rd root. So what we want to do here is this. We want to undo this cubed here. So the opposite of a cube is a cube root. What you do to one side, you got to do to the other. So we got to cube root this number to solve for d, and then we'll be all done. So the opposite of cubing, or the 3rd power, is the 3rd root, we call it. In Desmos, or Desmos Scientific, there's an nth root. Most calculators will have this. Sometimes you'll have to hit a 2nd key if you're using a handheld calculator. But we want an nth root, all right? Sometimes it'll say x and a y, and you've got to use that. All right, so we're going to go the nth root. So this is the cube root of, now we don't want to type that number out. We want to use the answer. Okay, this answer key gives us the last answer, and it drops it in there. And that's what we want. So 19.51, Okay, 511. All right, so 19.511. Now, the directions, we're almost done. The directions said we want to round this to the nearest eighth of an inch. Okay, so remember when we've done a lot of to the 16th of an inch. All right, so what we're going to do now is we're going to take this and get rid of that 19. So let's take the answer and subtract 19. That just gives us the decimal, okay? And then let's take that number and multiply it by, instead of 16, let's go by 8. If you did it by 16, it would tell you we have 8 16ths. Well, this is 4 eighths, all right? So it's close to a half, of course. It's 0.5, basically. So we have 19 and 1/2 inch is D. So that's how big of a beam or how tall of a beam we need if we want this moment of inertia here. All right, well, there it is. Okay, we got rid of the denominator. We divided, and then the new thing is the opposite of cubing is cube root. Hopefully that gives you an idea of how to work with these equations, dealing with squares and cubes and undoing them with square roots and cube roots.